Okay, today is May 10th, and now we have less than 1 hour. Actually, it's 45 minutes to finish this hard question. So today we got a hard question, which is, let me check, 1354. So it's construct target array with multiple sum. So this is a hard question, and yeah, so we got back-to-back hard questions. So I don't know how to. Yeah, I don't even know if we I have what I got to solve these problems. But thankfully, we have two hint. So let's try if we can. Yeah, solve this problem by looking at the hint. Okay, so let's try it. Let's try it. Okay. So the question is construct target array with multiple sums. So given an array of integers target from a starting array A consists of all ones, you may perform the following procedure. So let X be the sum of all elements currently in your array and choose an index such that target size. Okay, so choose an index and then set the value of A at index I to X. You may repeat this procedure as many times as needed. Okay, not quite sure. Okay, let's check the example. So the example is 935, and okay, the starting array is always 111. Okay, and sum is 3, and then we choose index 1 and set it. Oh, okay, so we sum them up, and then we can only replace number with the sum, and then we sum them up. It's now 3 4 5, and then we replace the third one as 5, and it sum up to 9, and then okay, so we cannot do this because the first sum of the initial array is 4, and yeah, you can reach this status. And also the target A5 is true. So for A5, I guess we can like start with 1 1 and then make the second one as 2. Oh, my mic. And then okay, my mic dropped. Yeah, so 1 1, and then the sum is 2, and then we set the second one as 2, and then 1 plus 2 is 3, set the second one as 3, and then 4, and then 5. Now we reach 5, set it. Okay, I don't know how to do it. Even for this one, I don't know how to do it. Yeah, okay. So let's see the hint. Give that the sum is strictly increasing, the largest element in the target must be formed in the last step by adding the total sum in the previous step. Thus, we can simulate this process in a reverse way. Okay, we need to do it reversely. Okay. And then subtract the largest with the rest of the array and put the new element into the array and repeat until all elements become 1. Subtract the largest with the rest of the array and put the element into the array. Repeat until all elements become 1. Okay, so the hint tells us to do it reversely because the largest one will be formed last. So then, oh, okay. So I guess we need a priority queue, right? Because you always find the largest in the array. And then we replace it until all the elements become 1. So do we care about the order? No, probably not. So we don't care about the order. And okay. So let's just follow the hint because we don't have much time. So let's just follow the hint. So we want to do it reversely, and then we need every time to get the largest one. So we don't need to, and we probably don't need to care about the order, but then we need to make sure that every element is 1. So if during the process we find anything that is less than 1, then we return false. Until we find the largest from the priority queue is also 1, then we turn true, right? And then we always subtract the largest with the rest of the array, so we need to keep a rounding sum. So first I need to have a sum of the entire array, and I also need to put everything into the priority queue. So let's try it. So let's get a priority queue first. Priority queue of integer. pq equals to new priority queue. And we need to put everything in the priority queue, and I want to get the sum of the, so I go through the entire thing in the array, and then pq.offer I, so we put I into the array, and then I want to have a sum, so sum equals to 0, and then we get the sum. Okay, so now we have the sum, and now we have the I, and then hold on, the priority queue should be reversed, right? So what do we do? Collections dot reverse or RTR. Is that do we have this? Collections dot reverse order. I think we do. Reverse order. Okay, I spell it wrong. Reverse. Okay. Yep. So now we have a reverse order. So every time we get one element from the array, so now and not array from the priority. So largest equals to pq dot pull, and sum minus equals to largest while what? While true. Let's figure out the condition later because I'm not sure the condition yet. So okay, while true, let's change the condition later. And then the largest is something that you pull from the priority queue, and then you minus this from the sum. So the sum is uh, the rest of the array, right? So you need to subtract the largest from the rest of the array. Okay. I'm strictly following the hint. Okay, so and then you want largest equals to sum, right? And then you put this, and now I check if largest is smaller, because if it's larger than 1 we can keep doing it, but if it's smaller than 1 return false, right? And then otherwise we put this back pq dot offer largest, and then we need to update the sum, right? Now we need to add this back, sum plus to equals to largest. I don't know, I'm just following the hint. I'm not even sure why it looks so short. I know this idea is not easy to come up with, so yeah. I mean, why can't I mean, why do I always need to do it backward though? Because from the hint 1, right? Because from the hint 1, you know the largest one will be the last one. So you know the order by reverse it, you know that you will be follow the correct order, because from the example 3, because if you do it forwardly not backward, you cannot always choose the smallest one, right? Because that will be wrong. For example, this, you are not always choosing the smallest one, right? So you put 3 and then you put yeah, but this is following this, but for this I don't think so, right? Because you put 1 1 become 1 2, and then if you choose the smallest one is 1 2 become 3 2, and then 3 2 become 3 5. Oh, but yeah, if you going forward you can still choose, I mean, for at least for these 3 example you are still choosing the smallest one, right? I think so. That's why I don't understand. I need to prove that by going forward I don't know which one to choose, right? But by going backward I know just need to always choose the largest. So it's easy to prove this, but when I read this I won't come up with this. Okay, let's try it. Unreachable. Oh yeah. So I need to like, and if like largest, can spell, if largest um if largest is 1, break. Yep. And let me check in here, because in here I can run every test cases like this. Okay, so it looks like we passed these test cases, but I am just wondering how about like randomly, but if I randomly put something, it might be false because it's so hard to come up with something that is true, right? False, false. Okay, so what's the constraint? 10 to the 4. Let me try to see, because I don't really think it will get TLE, because we are just using nlog n sorting. So even if I have so many, like, I should still not get TLE. Yeah, but it's really hard to come up with something that I can test it is true though. So should I submit? I mean, I really haven't learned anything. I mean, I can't come up with this idea if nobody give me a hint. Should we submit? Yeah, let's submit. Wow. Okay. So I follow the hint. Oh yeah, because one of them can get to this. And I'm just simulating, right? We still got time, so let's think about it. Give that this, what did I miss? Strictly increasing the largest element in target mass before. So I subtract the largest with the rest of the array and put the new element back into the array and repeat until all elements become 1. So I guess the most time consuming thing in this is priority queue. So now the thing is, we don't actually need a priority queue, right? We only need to find the max. And to find the max, do we just traverse? I mean, traverse through the array every time, because it's not n log n, it's n, right? So every time, yeah, but for priority queue, after you create it, each time you sort it, I mean, each time you add an element, it's only log n, right? And then if each time you pull an element, especially, yeah, it's still log n, right? Because it's just a red black tree, so somebody will start bubbling up to the top of the red black tree. So this should be fast. I can't come up with anything to find the max faster though. If priority queue is not fast enough, I don't know, I strictly following the hint and I fail with only 2 number. So it's not that priority queue is taking my time, it's this process is taking my time. So there must be a way that I can end this earlier. So I don't need to wait until the largest is smaller than 1. There must be a way for me to know it's false, right? How? Because only this is not in the hint. This is in the hint because repeat until all elements become 1. These two combined, I can make sure everything become 1. But how do I break earlier? I mean, how do I know this won't happen? I don't know. I already followed a hint. I still don't know how to do it. Yeah, I'm doing simulating. But what's the condition we can make it false? After I minus the sun, one, two, two, and this is 1. Right, because my termination works for this, but somehow don't work for this because it got time. So every time I minus 1, every time I minus 1. Can I do it faster? Subtract largest with the rest of the array and put the new element back into the array. Okay. 4 more minutes. If I can't think of anything, I'm going to read the solution. So this is a special case that we only subtract 1 each round, and then we can't afford 10 to the 9th round, right? Why I didn't think of this test case? But this is definitely true. But I should not make a special case for the 2 element, right? Because I could have, let me test. Hey cat, can you move? My cat is blocking. Okay. So let me try. If I deduct 2 each time, will I got TOE? I do. Yeah. So this is a extreme case that we need to deal with. Yeah, but my program for this one still got TLE. So even though it's -2 every time, but it's still not, my solution is still too slow because this is half time compared to this, right? Because this always -1 every round, but this always -2 every round. But still, I can't even do half of it in my algorithm. So there must be something Yeah, there must be something, right? I got 1 more minute. Yeah, but based on the hint, how can you do it faster though? I don't get it. It's just a simulation. Oh, 1 minute. How do I make it faster? Okay, I know it's time's up, but I want to try something. What if, what if this is still the largest, can you possibly use squares if they are all ones and a really big number? But that's special case. I don't want to like make it work for one special case, right? Then how about, you know, how about this? This don't have one, but this will still got TLE, right? So if you make special case, then you need to make a lot of special cases, right? So I'm pretty sure that this might still get TLE, and then if you switch to this, it will be my special case. But this will not be my special case, and this will still get TLE. So now what I think is give me 4 more minutes. So what if after I deduct the sum, and if the largest is still the largest, I don't put it back. You know, I keep, yeah. So what I think is that if this is -1, return false. Um, and then if like largest is still larger or equal than PQ dot peak, I mean, I just keep doing it. May I? I mean, so if I do this, while I can I even speak while when I was while this, do this. Right? Will it be faster? If I like if it's still largest, I keep minus the sum until it's not the largest. Let me try. Huh? Huh? What? Compile error? What? Oh, shoot. But the answer is wrong. Oh, no, 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 no. And largest not equal to 1. Okay. Do I want to submit again? Not good. It's surrounding. Oh god, null point. So 14, 14. Um, so we have a driver solution null pointer. so I cannot peek. So, oh god, this one is 1. So, there's a special case that if, I cannot type. I cannot type. If target dot length is smaller or equal than 1, return false, right? This is false, right? I mean, this is false, right? Okay, I somehow want to submit again. No. No. Okay, 5 minutes up. Is there any better way? I thought this will help though. Is wouldn't it be less than or equal to 1? You mean this? Yeah, but it got TLE. I guess it's still like not fast enough, right? So unless I can make this move fast enough, otherwise, even if I don't put that back into the queue, it still won't. Okay, I don't have something white. White. Gave up. Surrender. I am going to check the solution. Working backward. May I directly see the code? Oh, I missed this. Yeah, so I will be wrong anyways. And Java 8, right? Is this Java 8? Yeah, you get a sum by doing this. And then yeah, priority queue, yeah, reverse order. And then yeah, you add everything. Okay, but now this you can use Java 8. I mean, there must be a for each, like, right? You stream it and you for each, then you add. Oh, I don't know. Maybe I was wrong. Okay. While PQ dot element larger than 1. What is priority queue dot element? I'm not familiar with that. Sorry, I have to Google it. Retrieves but does not remove the head of this queue. What's the difference between this and peak though? Why don't you just use peak? Hold on, isn't this the same as what I'm doing? It's the same, right? I got the largest and then I minus this, minus totals this, and then if it's less than 1, so is that reason right after it? What? Wait, will this pass? Or this got TLE? Where did you see the reason? If you got approach one working but fail on large test cases, you are still doing really well. No, I didn't pass. I still have 10 minutes. Come on. You are still really well and have gotten that far. Oh my god, are you joking? A lot of people find this final organization really difficult. Oh, instead of pick, really? You mean in where? Is that right after in the documentation? Oh, okay. Really? I didn't really read it. The differ from, oh, okay. Only in the is throw exception if the queue is empty. But they are not catching any they are not catching any exceptions. So I don't know why you use element. But anyway. And then I guess this showed us that this one, the approach one, won't work. So what works though? This is one of the hard questions, especially for those with a limited background in mathematics. Are you talking about me? Recall that the workspace in the largest is larger than some of the rest. A good way to see what we need to do is to just compute the next few transitions. See this pattern? No. Each time the largest is being reduced by 5. Where does the 5 come from? It is the sum of other numbers. Yes, I know. Remember that huh? 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 I don't actually get this though. You need a mathematical proof of this because our our assumption is that if you're doing backward, you are following the right order, right? But if you are doing a mod, once you mod, you might not be the largest anymore, right? I mean, for example, I don't get it. For example, this one you keep you keep subtract by 5, right? But maybe you need to subtract the 5 times. Maybe the third time you already not the largest, and you still do it the fourth time, and you still do it the 5th time. I mean, if you want to make it work, you need a mathematical proof to tell me that it is still the right order, right? Am I wrong? Largest and the rest. And if the rest is 1, okay, this is also an optimization though. If the rest sum up to 1, you return true. But it's rare that, oh, that's the first optimization that we have, right? And then you got this. If it's 0, return false. If it didn't change, which means largest is smaller than rest, return false. Otherwise, you add it back. I don't totally agree without a mathematical proof. you know. Of course I know, okay, 4 minutes. Of course I know doing this while is essentially doing the mod. But what I mean is, you know what I mean? I mean, doing mod, you jump too fast. Maybe in between you already not the largest and you have to stop. But let's try it. So if I understand it correctly, they are just replacing. Yeah. Okay, so what we need to do is that if this, we need to just check if target 0 equals to 1, right? And then when you have this, and then you don't need this, and then I want to keep the largest. But why they declare an X though? I don't. Oh, because you want to compare if. What I'm going to do is that I can just compare, right? So if largest is smaller than sum, return false. And then you do this, and then if largest is equal to 1, I still don't understand. If it's 0, means that I still don't get it. If it's 0, means that oh, okay, it works because you check if it's 1 first. Because if large and rest are both 1, you can't do this. There are so many tricks in here, right? If you forget to do this, this won't work. So it's not only an optimization. You have to check if it's not equal to 1. Then you can do this check. Oh my god. This is hard of the hard. Because this check only works if large and rest are larger than 1. Whew. Okay, 3 minutes. If I don't see the... So now... so in my code, I will do... This is equal, right? If this equals to 1, then you just return true, right? So now if largest is equal to 0, then you return false. Otherwise, you put this and you do this. And let me try. Huh? Where? Oh, here. Okay, let me try again. Still? I'm not gonna pass today's. I mean, do I need to call it? What did I miss though? Is there a approach 3? No. I did the same thing, right? I checked. I sum priority queue, and if it's larger than 1, return true. Oh no, if it's smaller than 1, yeah. And then I peek. I get this. If they are 1, I return. If some are... Okay, hold on. Okay, I'm not gonna pass this. Not this. I don't see any different. Although I said true, but I did this in here. Oh god. Okay, I'm not gonna pass. It's already time's up. So I'm just gonna slowly... So I think I still need to do this. Now I know. What I miss is that you, in the while loop, you check the element. But I also check, right? So now I do this, and if it's 0, return false. And then oh god. Is that why I'm... No, that's not the reason. So I don't see why though. Do I need to strictly copy their code? Wait. Let me check again. Time's up, but... Okay, although this is different, but because there is a constraint, so it won't be 0. So this part is the same. I checked. Sum is the same because although you use string, the time complexity is the same, right? What do you mean? What am I doing? I mean, I'm still not passing it, but I think my code logic is the same. So I'm just checking why it looks different though. Ah, so you break when it's less than 1. And by doing so, it won't be less than 1, huh? Right? I mean, when you are doing the mod, how do you come up with a number which is less than 1? Modulo will always return positive number, right? So although my code looked like a mess, I don't see anything different. Yeah, I don't see. I know it looks different, but the logic is the same. Because doing modulo, you won't have anything in the PQ that is less than 1. So when you break this, you return true. And the same, right? I don't even need to check this because I won't have anything less than 1. Right? And I pull and I check if the largest one, then I break because it will be true, so it will be the same as this. And then you got the rest sum, and this is my rest sum. And then if it's 1, return true. And then you do the modulo, and then you check if this is the same. If this is 0, if 0 invalid, if x is now 0 invalid and didn't change, then we know this is impossible. Okay. But x didn't change means largest is smaller than the rest, unless my math is wrong. So I only see difference in here. So let me check. Let me not do this. Let me remove this. And let me not do this. Let me do what they do. So they checked if now it's 0, or oh, hello. I don't know. I think today's daily is also hard. Yeah, but if I want to compare if they don't change, then I do need to do a new. Then the code will be the same. Do I need to do this? Do I misunderstand the meaning of x equals to largest? Okay, okay. So I probably misunderstand this meaning, because I think this means that largest is smaller than sum, right? Because if these two are the same, which means that larger, or there's any other possibility. Yeah, so this is what I missed. I mean, today is super hard. First, you need to know you have to compare the x equals to 0. And then you need to know that if you need this, you have to check that it's not 1 first. Oh, it's not 1 first. Oh yeah, that's yesterday. Sorry, I already passed midnight. I didn't submit it on time. Sorry. Yeah, it's not today's. It was yesterday's. Yes. Sorry, I now understand what you mean. Yeah. Yeah, but anyway, I oh, if I use time machine on today's, I will be anyways. Yeah. Accept. So today is super hard though. Even their approach 1 won't pass. So their hint is based on approach 1 and it won't pass. Okay. So I'm curious how did they do in discussion? Backtrack? Backtrack? So problem is good. Test cases are trash. They probably already changed the test case. Oh, I don't, yeah. Well, but sometimes his solution is so hard that I don't understand. So yeah, they do the same thing. And total is 1 or A is 1, then it's true. Okay. And then, oh, if A is less than total or total is 0 or I is 0, return false. Okay, so I miss 1. I check this, right? I miss this. My original code, I check this. But I didn't check this. Okay. And then you do this and you do this. Oh, okay. So I guess for today's question, this is the only way to pass. There's no other way. There's no other way. And the good thing is, I think during the interview, unless the interview, they have a system to want you to commit the code on the whiteboard session, right? Otherwise, what company? Hey, yeah. You remind me to check what company asked this. Company. Okay. Anyway. Okay. So that's about it, I think.